Ride on the magic school bus.
Seatbelts, everyone. Hello, good morning. It's the environmental engineering Miss Frizzle. Happy Halloween, everyone. I hope you're going to have a great day today and a very safe time tonight celebrating. Just a couple announcements to remind you about. Today on Halloween, you can have a really good time and learn so much about optics and photonics if you head toward the Creole building. Everything starts at 11 a.m., so be sure and stop by our awesome Creole building to learn about the cool photonics and optics major. We've got some other really neat activities that are available to students. Something that maybe you may think, I'm not too sure if that's for me, but it's called Concrete Exposure Day, and it's being held on campus on Saturday, November 8th, right here in the atrium of Engineering 1 and 2. It runs from about like 9 to 3. The enrollment registration will be on the website on web courses for you. And, you know, it's one of those things where you'll learn about something you see every day, concrete, right? All the buildings, all the roadways. But, you know, maybe you don't slow down and really learn about it. So if you're interested, there's cool lectures. There will be companies that are doing very interesting displays and activities. And we always have really good door prizes at this event as well. If you are civil, environmental, or construction, it's really a must. It's a great way to spend a Saturday and learn lots. Also coming up, registration. I know some of you are a little frustrated, but you know, be patient, make appointments with your ASCs, and know that there are a couple cool courses out there. One in particular is CAP 1931, and it's a brand new course that the university is offering on all things AI, and how now as a student you can expose yourself obviously to using AI in a very positive way. Not to cheat, not to be lazy, but to enhance your education. Employers know AI is there. They're going to want you to join the workforce and be able to use it for good and help you get your job when you are working full-time done better and more efficiently. All right, so that course, CAP 1931, I encourage you to take a look at it, okay? Another big event coming up in the themed entertainment world is the Steel RSO has their themed entertainment panel, and it's an incredible event. They're pulling people from literally all over the world. There's a dinner involved, and so be sure and RSVP for that if you are interested in that as well. Today, we're excited because we have another incredible department to tell you about. It's the Electrical and Computer Engineering Department. Dr. Mike is taking us into his Draco lab. You'll meet Dr. Chris Iannella, who is an incredible veteran of NASA. He is honestly one of those people so well respected in his field that, you know, he could call the president of Lockheed Martin and he'd pick up the phone. We're very fortunate that Dr. Iannella is here now as a professor. So yeah, I want you to just, you know, pay attention, learn about ECE and all that they have to offer you. And finally, as Ms. Frizzle says, take chances, make mistakes, and get messy.
Hello and welcome. Have you ever thought about all of the technology around you? Ever thought, how does this work? How does my smartphone know what I want it to do? What if you could design the brains behind every smart device you've ever used? Connected devices from point to point, powered those devices. This is what electrical and computer engineers do. So come along for the ride. I'm Dr. Mike Brofchek, faculty member here at the Department of Electrical and Computer Engineering at the University of Central Florida. Let's dive right in. So first of all, ECE at UCF is the place that we'd like to say is where hardware meets intelligence. Electrical and computer engineering is at the heart of everything around you that computes, senses, moves, powers things, connects things. It is everywhere. It is the interface that all of the AI technologies that we see around us today interface to our physical worlds through. At UCF, we have 2 ABET accredited degrees in the bachelor's level and many paths through those degrees and otherwise. Our two primary degrees are Bachelor's of Science in Electrical Engineering, as well as a Bachelor of Science in Computer Engineering. We are the #1 supplier of graduates to the aerospace and defense industry. In general, we take ideas, make circuits, then systems to deliver impact. We've had recent growth at UCF, continued growth in our electrical and computer engineering programs. Again, our programs have massive industry connections, filled with hands-on learning. We have different pathways that involve design and development of chips, those things that go inside of our devices, robotics, power systems, RF spaces, so signals and systems. We're moving also into the embedded AI space. In general, we care about building things that matter, and we're doing it right here. As I mentioned before, we've seen an increase in enrollment. We've also seen an increase in our competitive rankings here in the US. All of this is backed by additional regional growth. As an example, the Florida Semiconductor Engine, located right here in Central Florida, is infusing over $100 million investment into the semiconductor industry, which is one of the major players within electrical and computer engineering. So, 90 seconds for what do we do in electrical computer engineering? We do things like computer systems and architecture. So that is, how do we build the next generation of computers, the inside workings, right? The chips that actually power these systems. How do we make sure that they're fast, secure, reliable? How do we move data and information, which actually is one of the biggest bottlenecks of today's systems? Moving on, we also have cyber physical and autonomous systems, designing robots, drones, smart machines. How do we connect the physical and digital world together? How do we deliver energy in those systems? Again, how do we use AI to adapt these systems? Going the complete other direction, we also worry and work on micro and nano systems. How do we build technology at these microscopic scales? How do we create these really small chips and sensors? How do we power those, right? As things get smaller, delivering power to these things becomes a lot more challenging. On the other side, electromagnetics and sensing. How do we design the systems that can see and hear, sense the world around us, right? That is antennas, radars, satellites at a distance. How do we enable communication across our globe and beyond? All of it comes down to, can we build the technology that allows us to sense and understand the world around us? Each of these spaces aligns to tracks that we offer within our electrical and computer engineering programs. So what makes ECE at UCF super special? Well, one, we have a great proximity to industry. Central Florida is huge in terms of all of the companies that exist all around us that have a variety of interests. There's a lot of different ways that you can get involved. Everything from the CWEP program, which is the Lockheed Martin College Work Experience program, to the Florida Semiconductor Engine, to the Space Coast. All of these are areas and developments that are right here in our backyard. As I mentioned before, we have different pathways through our major. We have 2 majors, 6 tracks within those majors. We have accelerated bachelor's to master's options. We also have graduate certificates, as well as specialized minors for those of you that are already committed to another space. By and large, one of the big selling points for our space is that we don't just focus on theory. It's theory and practice. We have smaller class sizes. Even our biggest classes are limited to usually under 80, though the target is even smaller at about 65. We have classes also that are often much smaller than that, especially when we talk about our special topics courses. All of this is coupled with the fact that you can engage in cutting-edge research. Ultimately, we want you to be able to prototype things here, get feedback immediately today, iterate tomorrow so that you can succeed. So let's talk for a moment about the electrical engineering degree. There are 4 tracks: a comprehensive track, a track that covers communication and signal processing, a power and renewable energy track, as well as an RF and microwaves track. I alluded to a lot of those things already earlier. All of our tracks have 4-year plans to help you stay on track. The big milestones in the EE degree, circuits and electronics are definitely up front, your core courses that are going to lay the groundwork for everything else. You then talk about how do you interface to the real world. So that could be courses on electromagnetic fields, control systems, digital signal processing, and a slew of others. And then you wrap up with technical electives and senior design. So if you're interested in power, energy, antennas, control systems, I'll say the general space of electrical engineering definitely fits. If we go and we look at the computer engineering program, we have two tracks, the comprehensive track, as well as the digital design and VLSI track, the second being the one that focuses on the creation of those circuits and chips. Again, 4-year plans help you stay on track. Milestones in the computer engineering degree, digital systems and computer organization, embedded systems, computer science, and then junior and senior design round out your space. Again, there's technical electives throughout as well. If you're interested in that intersection of hardware and software, definitely the tracks for you. All right, so perhaps you're already decided, not really ready or interested in switching. Definitely you can still explore. We've got minors as well as engagement opportunities through research. So brand new, we have an electrical engineering minor as well as a computer engineering minor that should fit most other majors, especially within CECS. We have also an intelligent robotic systems minor, so already intersects many other disciplines. So definitely check that out. There's also opportunities in other spaces like engineering leadership minor certificates, which you probably have heard about in other spaces, as well as a brand new honors undergraduate thesis certificate. Basically, there's a research certificate out there. It couples nicely if you're already doing the HUT program and others. So definitely check it out. And we are always happy to help. So how are you going to supercharge your career? Like as you get started, what is going to make you different than everybody else is looking for a degree? Well, you could consider perhaps looking at accelerated pathways, whether that's in ECE or other spaces. Many of our units here offer some kind of program like this, but in ECE, we have two. We have a EE and a CPE track that essentially allow you to count 12 graduate credits twice. So you get to count it for your bachelor's as well as your master's. It gives you a huge head start. Maybe a master's isn't what you're looking for. We actually also offer 6 graduate certificates that would layer nicely on top of an undergraduate degree, right? So control dynamics, semiconductor engineering and manufacturing, again, pairs very nicely with the fact that Florida Semiconductor Institute is right here infusing $100 million into Central Florida. There is a sustainable and resilient energy systems track certificate. There's technology for smart communities, and soon, pending approval from a few spaces on campus, a verification and validation of digital systems. So why tell you this now as you're just getting started in your UCF career? If you plan now, plan early, you can save time and tuition money, right? You can get ahead by just doing a little bit of extra planning now. Put this on your radar, but don't put off thinking about it for too long. So this is a pretty typical sequence, but we offer obviously some very interesting senior design spaces. So usually it starts off with a senior design lab. We have a very specific focus for junior to senior design, which lets you test out, try out the process of how do you build something from scratch. You get to engage with real sponsors. For example, we have senior capstone projects that have been sponsored by AMD, Lockheed Martin, Leidos, Northrop Grumman, and many more. You get access to the same spaces that you have already been in and more, including the TI Innovation Lab, the L3 Harris Gathering Lab, and others. Ultimately, you get recognized for the work you do. You can join about 400 other student presentations to get to basically present your work to industry judges, and just know that ECE is usually one of the top project winners year after year. So we are really worried / concerned about you creating designs that go beyond theoretical. We want you to build working systems, and we have a pipeline to help you do that. So the other thing I've mentioned is research. You can join. You could be a freshman, you could be a transfer student, you could be a sophomore, junior, even a senior. You can join any one of the research areas that exists within our space. I list again a lot of the different areas of interest that we have, without mentioning them again. I want you to know that you can do anything from artificial intelligence, power and energy systems, working on biomedical devices, secure hardware research, creating new and novel hardwares. Research is for everyone, including first-year students. So here's an example from your host, me, Dr. Mike, one of 50 plus faculty in ECE, offering both a course over the summer in Barcelona, right? So that you could get ahead, take a technical elective, or if you're CPE, VLSI track major, the course is actually required. You could take this in a very unique setting, Barcelona, Spain, 4 weeks, 3 credit hours. That is an opportunity. Again, that's one of 50 faculty in our space. That's one unique offering. There are others, not necessarily in a broad spaces, but it could be a special course that gets offered. On the right-hand side, I run a research lab. That research lab features students that are just like you, from freshmen to seniors and graduate students as well. Again, there are many of these labs that exist across the department, offering different engagement and opportunities throughout. So explore. When we're talking about opportunity, there's obviously a great community in clubs. So we have an IEEE student branch at UCF. IEEE is the recognized organization for our profession. We have an honor society as well. There's a robotics club, night hacks, women in EE and CS. I challenge you, right? And hopefully you've heard this from others, to find a club, find a community, and engage with them. I challenge you to do that before the next break. Can you find a group to start talking with and engaging with before we go on break? We also offer more traditional opportunities in terms of funding, right? But I think we offer many more than a lot of other spaces. So you can look at this list here. We offer something like 8 to 10 different scholarships that are related to corporate spaces and funding. You can get paid to experience, to learn, to do research, and then transition that directly into an internship opportunity. So we have these with, obviously many of you have heard of the CWEP program, which is not technically an internship, but it is an experience. It's a work experience. But we have research fellowships with AMD, Intel, Northrop Grumman, Texas Instruments, TSMC, and many more. I urge you to try to intern before your junior year if you can. Explore the space, see if it's something you like. I'll also mention that ECE, as well as other departments in the college, are offering internship for credit, where you can actually get, at least in ECE, credit for up to 3 hours of a technical elective by taking internship for credit. So explore that option. The usual requirements is that you have to apply before the internship starts. And yeah, that's pretty much the biggest one. There are some restrictions. Do a search for UCF CECS internship for credit, and you'll find a page all about it. So the question that all of you should be asking right now, even though you might be a few years from graduation, how are you going to move your career beyond just sitting in front of a computer? Clearly, there are massive advances in the ability for AI and machine learning algorithms to do a lot of work that we used to do. Not talking about the quality of it or anything like that, but the question is going to be, how are you going to go beyond just interfacing with a computer? So perhaps you're already decided, you're already an EE CPE major. Awesome. Go download your curriculum flowchart, figure out what you're going to do, meet with advisors, talk to professors in your classes, join a club and or a research lab. Maybe you're already decided another major and you're like, I'm not switching. Check out our minors and certificates. Perhaps there's something that boosts what you're already doing in another space. Take a hardware and embedded systems elective. Again, join a club or a lab. Completely undecided? Join a club. Talk to students. Explore current research. Something might click and let you figure out where to go. So, all right. So what now? Take the first steps. Explore. It's on you. So go visit ece.ucf.edu, find out some more details about some of the things that I just briefly mentioned. Go explore the minors, the tracks, the certificates. Go dig deeper, find out more information. Finally, reach out. Go find a student, a faculty member, a research lab. And then here you go. This is that page, ec.ucf.edu, you can go and find these exploring opportunities. Go look at the academics here. You can go look at student life, which is where we keep a lot of our scholarship opportunities and a lot of those other resources. And then figuring out who to talk to or what's going on, go look at the research and the people tabs. On the right-hand side here, we have Reza Abdelvan, our department chair, as well as Dr. Sundram and Dr. Lin. If you have an undergraduate question, Dr. Sundram is your person to go to. He might direct you also to Charlize. If you have questions about our accelerated BS to MS program, Dr. Lin is the person to talk to. And in general, if you're trying to figure out something and don't know where to go, Dr. Reza, Dr. Abdelfan is amazing and is an amazing champion for all of you. So reach out anytime, and we're always happy to help. Again, I'm Dr. Mike here in ECE. It's been a pleasure. And with that, thank you, and looking forward to meeting you all.
Hi, my name's Chris Iannello, and I will give the next segment in your introduction to the Electrical and Computer Engineering department. I recently hired back into the department because I wanted to spend the last few years of my career educating you, the next generation of engineers. Prior to that, I had served 36 years in the space sector, most recently as NASA's Technical Fellow for Electrical and Power. This is kind of its senior engineer in the discipline, and I had the responsibility, the honor really, of leading teams of specialists solving NASA's toughest technical challenge, whether it be in design, during development, or on flight even. Anything that went wrong in electrical or power, I was the tip of the spear to resolve. I was very successful at it. It was a wonderful career, and I was recognized for that success. I received medals from the president, the administrators of NASA, and from flight crew for my efforts to improve crew safety. UCF had a big hand in that. Think about this. When you look at the space business, it's largely a mechanical field. Of the 19 plus discipline heads that are there, largely mechanical fields, fluids and dynamics and propulsion. The two that are derived from electrical and computer engineering, that being the technical fellow for avionics and the technical fellow for electrical, interestingly, were both educated out of this department. So while there's no denying UCF's had a tremendous regional impact on the workforce, at a national level, this department educated the most senior engineers. The second thing I wanted to highlight is, and you hear a lot about this, is the strong relationship between industry and the proximity to industry that UCF has. In my case, it really helped my career. As a bachelor's student, I was a first in college for my family student. I didn't really have the direction. I needed that, and I needed the funding. The internships at the undergraduate level made for both of those things to come to fruition. Even more importantly, maybe, when I got out into the workforce and worked for a few years, I was able to see what I really wanted to study in the future. So when I came back to my graduate studies, I could select the programs that were of the greatest interest, the things that I knew that I was interested in and passionate about. And then when I got into those programs, when I encountered something that I knew from my career experience that it was of critical importance to my success, I was able to be laser focused and study hard. I think those things really prepared me to be as successful as I was in my field. And I think that can only be possible at an institution that allows you to so seamlessly move between academia and industry back and forth in a way that one informs the other. So now with that, suggestions on how to make the most of your time at UCF and beyond. As we approach this AI revolution and we don't know what the future holds, if I were you, I would consider fields, specialty areas that interface with the physical world. Power electronics, my field, is a great example where you drive the motor, where you store the energy, where you convert the energy from one form to another. But there are others. Linear control systems, RF communications, antenna design, embedded electronics, FPGAs that are embedded in the hardware very close to the physical interface are all great choices. But if these aren't your primary interest areas, that's okay too. Consider a minor if for no other reason than to hedge your bets for this uncertain workforce that you may be entering in the future. Next, internships early you always hear, and certainly important, but I offer you a different spin. Try not to lock in on an employer or a field of study too early before you've had a chance to explore your options. I think too often we as engineers, once we make a selection and we see a targeting solution on success, we put the blinders up and we execute. Don't do that. Take all the opportunities that you have now as a UCF student to look at different clubs, look at different internships, look at different employers, look at different fields of study, move between them all, even consider going backwards in order to basically find the best fit for you. Even if this means spending more time at university, because you have the time and it's a very important decision. And then lastly, and most importantly, no one is more responsible. Realize this. No one is more responsible and accountable for your success than you. With each previous graduation you've been through, hasn't it been true that the responsibility for your learning and whether you're successful or not is more squarely on your shoulders? That's true too here at your time at UCF. Don't let any small obstacle stand in the way of you being successful in your academic studies. And when you get out into the workforce, it's even more so true. Don't expect anyone to hand you a textbook or a playbook on everything that you're going to need to know to be successful in your job. Realize that, like with all those previous graduations, this next graduation and successive roles and promotions that you'll have professionally all mean that the responsibility for your success, your personal growth, your learning rests squarely on your shoulders now and in the future more than ever. So I want to leave you with that idea and that perspective. And I want to say that I'm very excited to have a hand in helping you be successful at your time at UCF. And I'll be even more excited to see all of the wonderful things you do in your careers that follow.
Hi, welcome. I'm Jordan.
I'm Alicia. This is the Draco Lab.
Please come in.
First, we're going to start in our coffee corner. We would love to offer you a warm cup of coffee. Thank you so much for joining us today. In this area of the lab, we have snacks for our researchers to stay fueled. We have a mini fridge if you need to drop off your lunch or energy drink, microwave to warm stuff up, and even a printer that prints for free.
All right, let's head over to the workbench.
First off, hi, my name's Alicia Tony. I'm a graduate student in the lab here. I have my bachelor's in computer science and I'm working on a master's in computer engineering. I lead one of the projects called Signal Insight, which you can check out on our website at thedracolab.com. We're also on LinkedIn, so please reach out to us there as well. And I've been in the lab for over a year now. I kind of help with maintaining the infrastructure, onboarding new students, and all the other fun things that come with that, like this video.
And I'm Jordan Merkel. I'm currently a senior in computer engineering here, and I've been in the lab for about 3 months, so I'm very new. But what I do in the lab is I help support Alicia's project that she's leading, Signal Insight, and it's been a lot of fun to get into research and learn a lot of new stuff.
Awesome, thanks Jordan. So a little bit more about the Draco Lab. It stands for the Design of Resilient Architectures for Computing, which is really just this great umbrella term that allows us to do all sorts of fun things. So we're not really limited to just like a very specific niche area of research, but just robustness, meaning doing things better. And that could mean faster, that could mean more securely. So a main area of our research is called side channel research, which means looking at a system and seeing, is it leaking any information that we can use to then attack the system? So like a really great example of this is when you log onto a website and it tells you incorrect password, you know that the username you used is right. So like, okay, you're like, at least I got my email right. What password did I use? But that's information leakage. And so there's a lot of projects in the lab that look into side channel attacks and how you can use that information. If you observe up top, we have some of these great workstations that we use to do our research, one of which actually is donated by our lovely sponsor, AMD, who is just down the road. And we actually have a lot of sponsors in the lab, like
Northrop Grumman,
IBM,
and AWN.
and as well as the University of Central Florida.
Okay, first stop on our tour is the Snow Nebula office. Fun fact about the Draco Lab, all of our rooms are named after nebulas in the Draco constellation. So let's see who's in here.
OMG, Jordan, Alicia, what's up?
Hey Josh, what are you up to?
I'm working on my senior design project, which is in collaboration with Northrop Grumman, who also works with the Draco Lab. So I get the opportunity to do their project, as well as other things as well, including engaging in research with them. The project that I'm under is called Dark Logic, where we are assessing the capabilities of LLMs in the creation of hardware Trojans to see if they can surpass or bypass verification. So yeah,
Thanks so much, Josh.
no problem.
We'll tell you a little bit more about this space. This is our docking station for undergrads, so they can bring their own laptops in, come use the available monitors here, hang out with each other, collaborate. It's just a great space for our undergrads to come hang out, get some work done. And now that you've seen our undergraduate space, let's move over to our graduate cubby, which is actually the Sunflower Nebula.
Bye, Lisa.
And
Bye, freshman.
bye, Josh. Let's see if anyone's in here. Oh, hey, Franco. Do you
Oh, hey.
have a minute?
Oh, hey guys, how are you?
So this is actually our graduate space, and Franco is an undergraduate project lead, but he hangs out in here with us because he's constantly collaborating on projects with us, helping us out, consulting, all the great things. How's it going?
It's going well, keeping busy.
What project are you working on right now?
So right now I'm actually working on our project Dark Logic, where we are taking a hardware description language that's used to create computer chips, and we're actually inserting malware using generative AI to see if we can actually bypass some of the formal verification that's used to make sure that the chips are what they say they are when they go into production.
That's so sweet. What's been the best part about being in the Draco Lab?
I think honestly the flexibility to work on all the projects that I'm really passionate about. It has been an awesome experience to be here.
It's so wonderful when we meet really passionate students like Franco because, yeah, they always find a home on one of our really interesting projects. Thanks so much for your time. Good
Anytime,
luck.
guys.
Awesome. Now we're going to continue our tour in our last space, the Cat's Eye Nebula, and let's meet back up with Jordan.
All right, let's go into our last space, the collab area.
This is a space where a lot of our researchers hang out, both undergraduate and graduate, and we're going to start by talking to Gabe here. Hey, Gabe.
Hey everyone, I'm Gabe. I am a current computer engineering master's student at UCF in my second semester. Currently in the lab, I work on an industry-sponsored project, so I can't unfortunately share too many details. But what I can say is I'm very thrilled to be working with the industry sponsor. It really provides a great combination of both research and industry experience. And it's been a lot of fun so far, and I can't wait to share more with hopefully future lab partners.
So now we're going to talk to Danny, who is also a graduate researcher in the lab. Hey, what's up, Danny?
Hi, I'm Danny. I'm a master's student for computer engineering.
What's your favorite part about being in the lab?
My favorite part about being in the lab is definitely the collaboration, like knowing that regardless of how tough a problem might be, being able to work with co-workers or associates and get different inputs in order to accomplish that task.
That's awesome. Thank you so much. Let's move on to our next person.
Hey Sebastian, can you introduce yourself?
Hi Jordan, I'm Sebastian. I'm a junior in computer engineering. I'm working on the encrypted processor project. And one of the things that freshmen should know about for the lab is that there is loads of support from all the people around you. From our very knowledgeable graduate researchers to your fellow undergraduate researchers. There are loads and loads of people that are just willing to help you out.
Perfect, thank you. Okay, now we're gonna go over to Donald and see what he's up to.
I see you're working on a microcontroller. Can you tell us a little bit more about what you're doing?
Yes, this is for the Chirp project. Basically, it's just a mesh communication network protocol. What I'm doing specifically is I'm setting up a UART communication with computers so we can get all our data back off. It's lovely to have a team because we can break up all the tasks like this. One of the great benefits of the Draco Lab.
Awesome. Thanks so much, Donald. We'll head back out to the main center.
We hope you've enjoyed our tour. We think that undergraduate research is really important, especially like with my experience. I've really enjoyed the network that I've gotten from being in the Draco Lab and getting to connect with other grad students, undergraduate students, and professors.
And my favorite part about doing research in general, I've done it as an undergraduate and a graduate. And the best part is in class, you learn a lot of theory and you don't have as much opportunity to do things hands-on. And research is a great place to get started with that hands-on learning, that applied learning, both undergraduate and graduate level. So it's really great for everyone. Thank you so much for joining us today. We hope that you've enjoyed learning more about the Draco Lab, our space, talking to some of our students, and we appreciate your guys' time so much. All right, everyone, say bye.
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 What's up, everybody? My name is Joshua Joseph. I'm a senior studying computer engineering here at the University of Central Florida, and I'm here to talk to you about ACM, which is the UCF student chapter of the Association for Computing Machinery. ACM is dedicated to developing your professional and technical skills through our workshops, general body meetings, networking events, and projects. We're open to computer engineering majors, computer science majors, and electrical engineering majors, but we have opportunities for other majors to get involved in interdisciplinary work. We've had the opportunity to collaborate with a bunch of awesome companies, including AMD, Blue Origin, Siemens, and others that one day might hire you. So come to our club, get to know us, network with people, get to know what you can do to be a better engineer and how you can get your dream job and accomplish your goals.
Hi everyone, I'm Chinmai, the president of WEEKS, Women in Electrical Engineering and Computer Science. We are a wonderful organization for those interested in electrical engineering, computer science, and computer engineering, but honestly, we welcome everybody who's just curious and wants to learn something. We do a lot of professional development, workshops, and projects, which are all beginner friendly, and it's just a way for you to learn and build your skills and also meet a lot of new people. Our next GBM is going to be on Tuesday, November 4th, so we would love to see you all there. And if you take a look, you can scan our QR codes for our Discord and our Instagram, where you can stay up to date on all of our information and stay connected with us. Hope to see you there.
Happy Halloween! Hi, I'm Allison. I'm one of the TAs. I'm a senior mechanical engineering major. I have minors in math and political science. A little fun fact about me, I own like over 30 board games. I'm a big board game fanatic. Who are you?
Hi, I'm Brooke. I'm, as you might have guessed, also one of the TAs. My major is mechanical engineering. I have a minor in environmental studies. I'm in my third year. I'm a junior. And a fun fact is that a lot of people think all of your bones are fully fused by age 30, but actually some of the plates in your skull won't fully fuse until you reach about 60 years old. Just a little Halloween fact for you all.
Wonderful. So a little bit of advice for you guys is, form a little buddy system. Work with other people, Don't do college alone. That's kind of boring and sad. Have some fun, do study groups. It's good to have friends.
And another fact for you all is you're freshmen, so you might not be thinking about graduation quite yet, but as you get closer and closer, make sure you check what the prerequisites and co-requisites for the classes that you have to take are, especially for something like senior design, so that you're not stuck delaying your graduation by a semester because you realize a little bit too late that you've done things out of order.
Yeah, if you're ever unsure about something like that, talk to an advisor. You can make appointments pretty easily, so just get it cleared up as soon as you can.
Yep.
All right.
And now we'll pass you guys back to the GTAs.
Bye.
I can't be the only one who hears you.
Hi everyone, welcome to Go for Launch with the GTAs. Today in lecture, you heard from the Electrical and Computer Engineering Department, or ECE. You got to hear from Dr. Mike and Dr. Chris, a NASA alum, and some really cool EE clubs.
You also got to meet two of our awesome TAs, Allison and Brooke. And now from a pivot to lecture, we're going to give you a little preview of what to expect in lab next week. So your final launchers are going to be due. So you had those prototypes due in lab this week. Next week, those final launchers will be due because you are going to be practicing with the final competition code. So you're going to be using the tracks that we have in the lab, and you're going to get a feel for what to expect for that final competition. The next thing that you guys need to look out for, lab, is that we are getting robots set up and ready for you guys to check them out, so you can practice inside the atrium outside of your lab as well.
Yep. We'll make sure that there's signups and it's clearly communicated to you through your announcements in web courses, so stay tuned for that next week. One other thing in touch of lab, that Excel capstone project, be sure to start working on that and getting your bonus belts, get all the way up to that black belt certification in Excel and put that on your resume. And with that, we hope you have a very spooky haunted Halloween. Be safe, have fun, and here's your quiz code. Bye! Can I stop waving now?